today's lesson we're finding the volume of pyramids and cones. Now that is very similar to finding the volume of prisms and cylinders, which we did just a couple of days ago. The volume of a pyramid is found by using the formula volume is equal to 1/3 the base times the height, where B is the area of the base actually and H is the height of the pyramid. Now I want you to remember, when we were finding a cylinder that, a prism that had a square base, we would just find the area of the base times the height. So when we come to a point at the top forming a pyramid, instead of going straight up with our sides, what we end up with is actually 1/3 of a prism that would have the same size base. So when we get our pyramid, we treat it like a prism, except we take 1/3 of it. Same is true of a cone in relationship to a cylinder. It will be 1/3 of the area of a cylinder that had the same size circular base. So finding the volume of this one, we're going to do 1/3 times the area of the base times the height. Since the area of the base is a right triangle, we have 1/3 times 1/2 base times height, so of the actual base of the triangle, and then that gives us 36 meters cubed. Here we have a cone. That cone will be 1/3 of a cylinder that had the same size circular bottom. So 1/3 of the area of the base. Remember, the area of a circle is pi r square. So 1/3 of pi r square times the height. When I plug in, I see that I get 7.26 pi, which is about 22.81 cubic centimeters. Originally, the pyramid had a height of 144 meters, so we got a height of a pyramid. The volume is 2,226,450 cubic meters, and we're looking for the side length, and notice it says it has a square base. So for our square base, we're going to have to find the area, or know how to find the area of a square base, which is just a side squared. So I plug in my volume, my 1/3, since it comes to a point. The area of my base, since it's a square, is simply x squared, and my height is 144. So from here I'm just solving the equation. I multiply both sides by 3 to get rid of the fraction. I divide by 144, and then I take the square root. So it looks like the side length is about 215 meters. So here's one for you to try. This one is a little more difficult. You're going to have to think back on finding the area of that hexagonal base. You end up with 152.42 cubic yards. Now let's see how we got that. Remember what I need. I need my volume is equal to 1/3 the area of the base times the height. So I've got 1/3. I need to find the area of the base. It gives me the height. Now how do I find the area of that base? Remember that we look at the center and we make us a right triangle. And so dealing with that right triangle, this is the apothem, because remember the area of a hexagon is 1/2 the apothem times the perimeter. To get my apothem, remember that this side will be half of the length of the entire side there, so that'll be 2. But that's the only figure I have, so I need this area, this apothem over here. So what I need to find is either the length of this side in order to use Pythagorean theorem, or I need this angle. Well, let's see if we can get that angle. Remember that my central angle is 360 divided by the number of sides. In this case, that's 60 degrees. That would be the entire central angle, so this half is 30 degrees. So 2 is the opposite side, the adjacent side is the apothem, and I can either use the tangent of 30 degrees, or I can remember my 30, 60, 90 triangle, where the long side is the short side times the square root of 3. So 1/2 times 2 square roots of 3. My perimeter, I've got 6 sides of length 4 yards, so that is 24. So my area of that base is found right here. So 1/2 of 2 square roots of 3 times 24. And if you punch all that in, that should be what you get. Let's look at that and see. I'm going to switch to my calculator, and I'm going to go ahead and take care of this. So I've got 1/3 multiplied times 1/2, we'll just put 0.5 for that, multiplied times 2 square roots of 3, multiplied times 24, close that off, and multiply the whole thing by 11, and that should give us our 152, and you can see that it does. So let's get rid of that and go back to our program here. A right cone. So we want the volume of this right cone. So what I need is 1/3 of the area of the base times the height. Well, that is 1/3. Remember, my area of my base, that is a circle, so it is pi r squared. So pi times 5 squared, and then multiply that times the height of 8, and that should give us our volume of that right cone. Oh, we have another problem that I wrote over. Let me get rid of that writing, and then we can read our problem we need to do. What we're trying to find is the volume of a right cone is given to us, and the radius is given to us, and we need the height. So I hope you've tried it. The height of the cone comes out to be 12.5. How do we get that? The volume, 1350 pi, is equal to the area of the base, which is pi r squared, so 18 squared times pi, multiplied times the height. So I simply need to divide both sides by 18 squared pi, and that will give us our height, and it should work out on our calculator. Another example, finding the volume of a right cone. Notice what information it gives me. It gives me an angle outside here. This is 65-degree angle. It gives me the height. So remember what I've got to have. I've got to have this radius, but I also need this lateral height, or the slant height. And so I'm going to use trig to do this. I set up my little right triangle. What I have is the opposite. For the radius, I'm looking for the adjacent. So I'll use the tangent of 65 degrees is equal to opposite over adjacent, and I will end up solving that for r. Get about 7.46. So that gives me my radius. Now I need to use the formula for finding the volume of a cone. I don't need the slant height for that, do I? So 1/3 pi r squared h, which is the area of the circle, so 1/3 pi times 7.46 times 16 gives me my 932.45. When I was thinking of this lateral area, I was thinking of finding our surface area, but we're doing volume now. Find the volume of the solid. Notice what I have is actually two solids put together. We have a square cube, or a square prism or cube, and then we have a square pyramid sitting on top of it. So I'm going to put these together. My solid is the volume of the cube and the volume of the pyramid. The volume of the cube is simply the side of the cube. The volume of the pyramid is 1/3 the base times the height. So I've got 6 cubed, 1/3 times 6 squared times 6, and so it comes out to be 288. That one's not too bad. Here we have a funnel shown to measure the coordinates of a particular type of sand. It takes 2.8 seconds for the sand to empty out of the funnel. Find the flow rate of the sand in millimeters per second. Well, what we need to do then is we need to find that volume of that. So I'll find the volume of the funnel by doing my 1/3 power square h. Simply plugging in the numbers it gives us, it's 101 centimeters cubed. Now it takes 2.8 seconds to drain out that 101 centimeters. So 101 centimeters cubed is a milliliter according to the information we're given up here. So divide the volume of the cube by the amount of time, and it comes out to be 36.07 milliliters per second. So here's one for you to try, finding the volume of the cone at the right. Remember, what I'm going to have is my radius here. So it's 1/3 power squared h, 1/3 h times 4.87 squared times 5.8 comes out to be 143. Now, where did this 4.87 come from? Well, what we had was we had the adjacent, we were looking for the opposite, so we simply used the tangent of 40 degrees is equal to the opposite, which is what we were looking for, our radius, over the adjacent, which was 5.8. So we solved that for x, and that's where we got our 4.87. A right cylinder with a radius of 3 and a height of 6 has a right cone on top with the same base and a height of 5. Find the volume of the solid. Comes out to be 330. How do we get that? We need the cylinder plus the cone. We need the cylinder area of the volume of the cylinder per volume of the cone. Remember that my volume of my total volume, so my volume of my cylinder is going to be power square h, so pi times 3 squared times, it says the height of the cylinder is 10, plus the cone, which is 1/3 3 squared, pi r squared, 1/3 pi r squared times the height of that, which is 5, and that should give you your 330.